This afternoon is dedicated to recycling for the footwear and apparel industry. Ms. Alio has been so kind to introduce us to the priorities of the European Commission, to this concept of the Green Deal, and more specifically, the concepts of a circular economy. Recycling, reusing, making good use of materials, keeping them in loops in order to relieve the problems we are causing in our environment. This afternoon and tomorrow will be dedicated to an introduction to the topic, because recycling is these two sectors is a very complex issue. We are talking about lots of different materials with different properties, requiring different processes in order to reuse them, in order to recycle them. So these 2 days are meant as an introduction. We will touch what is best available technology. Details we will follow up. If you have any question, feel free to put them on the table, especially everything that is linked to applying these concepts and these technologies in your enterprises. And in the follow-up, we will deal with all these questions, and I'm quite confident that we can come up with good solutions. Actually, this is pretty much the topic of tomorrow, to discuss a potential way forward. Because as we say, Rome was not built in one day. Also, a circular economy will not be created within a few weeks or months, but it requires a constant questioning of practices, of materials, of business models even, and step by step adapting them to our specific situations. So, having said this, what are the topics for this afternoon? We will continue immediately here with shining a little bit light on the background, showing a light on the situation of the sector, discussing material flows, discussing what makes this sector a priority in terms of circular economy. We will explore, just in brief, the legal background in Europe. Was already mentioned, the Circular Economy Action Plan, Green Deal. All this is setting a framework for the years to come. And then we will continue with a few key technologies used in recycling. After this, we will continue with an exercise so that we can start discussing all these recycling opportunities. We will continue then with more specific recycling technologies used in the footwear sector for the rest of this afternoon, and exploring in another exercise what might be potential recycling opportunities applicable to our industries. Feel free, and I'm inviting you to engage in a discussion. As I tried to say, we can lay the ground today, but we will have to follow up many details regarding applicability, economic viability, and so on of all these approaches. But I'm quite confident that we will discuss a few ideas. Many of them you probably already are familiar with. Some of them might be new and might show the way So, having said this, let me starting by exploring the background just briefly in 15 minutes, going through European legislation, the reasons why this legislation is there, and the way this legislation is showing. To start with, a few numbers. We have heard today already, and I know you are familiar with this, not only in Ukraine, apparel, garment, footwear is a very relevant industry. Looking at European numbers, the whole sector, the broader sector, is generating more than 80 billion of euros in turnover. This makes it a very relevant sector, involving lots of jobs and generating a lot of GDP. What does this mean in terms of material flows? Now, looking at the EU 28 still, because these data are from 2017. These data which are on the screen showing textile material flows per person, per European citizen, telling us that 28 kilograms per person and year of textiles are imported, 7 kilograms are produced within the European community, which means the final consumption of textiles per person and year is 26 kilograms. Just to show the magnitude, if we multiply this by a number of European citizens, this gives us an idea what we all have in our cupboards. And this also gives us an idea of one of the main problems, which means very short life of textiles, fast fashion, as the buzzword goes. Just to add on this, the average European on an annual basis buys 6 pairs of shoes. And this includes not only women, but all European citizens. So the whole sector of textiles, garments, and footwear is a very relevant sector in terms of GDP, as we have learned, but also in terms of material flows. And this makes it a priority sector, one of 4 priority sectors actually within the circular economy strategy. Now, a bit small, sad observation regarding global material flows. These numbers here were collected by the Ellen MacArthur Foundation, the path leaders in circular economy. If we look at where the feedstock to the textile industry goes, we see that we have 97% of material flows as virgin fiber feedstock, some 2% recycled feedstock. These are the PET bottles which are processed into yarn. This is a little bit rubber, which is recycled. We see some closed loop recycling. If we look very within the industry, about 1% of total material flow is recycled. And we see some recycling of textiles, actually, of used textiles. But if you look at the overall numbers at present, or actually for 2017, this Sankey diagram tells us that more than 70% of all the fiber feedstock which is supplied to the textile industry and which is processed into garments at the end of the useful life is either landfilled or incinerated. And this is definitely not what it should be. This is now the focus of all these discussions, directives, plans to reduce the number, showing the amounts of textiles that go to landfill or incineration, and to increase the quantities which are recycled, either in a cascaded way, downcycled, used at cleaning rags, whatever, or as garments, reusing textiles, and also, and this is our main focus today, to increase the volume of fibers and materials which are recycled within the industry. There are many opportunities, and we will continue to discuss these opportunities tomorrow. There are many opportunities. However, as we see from these numbers, at present, they are very scarcely explored only. And all these discussions which we want to trigger, and all this discussing best practice, best available technology, shall lead in the medium and long term that we pick up on recycling, that we use these technologies. So lots of numbers, some more numbers, just to give you a full picture. As it's a big industry, also pollution resulting from the industry is significant. These numbers were compiled by McKinsey. The absolute quantity is big in terms of carbon emissions. Also interesting in this chart is where actually in the sector carbon emissions are triggered. A lot of emissions is related to materials production, giving good reasoning for increasing the volume of recycling. And also then in the preparation of yarns, in processing, in finishing fabrics, and then to a lesser degree in producing the actual garments. Relevant is also the use of the products. This means all the washing, drying, ironing of garments. So to combine all of this into a clear message, we have several documents by the European Commission. The European Commission has identified apparel and footwear as a priority product category for the circular economy. Also considering the numbers which we have just discussed, a new circular economy action plan will be announced, focusing on the elements which I'm going to introduce to you in a minute. And the European Commission explicitly recognizes the importance of education, of knowledge, and behavioral change as an important basis for the shift towards a circular economy in the textile sector. There are two very relevant directives. One is a little bit older, the Directive on Waste of 2008, which was replaced in 2018 by a new directive on waste with a few key elements. The new directive explicitly encourages the reuse of products and the setting up of systems promoting repair and reuse activities for textiles. This sounds common sense, this sounds a commonplace, but is not anymore. The keyword was fast fashion. It has become usual in some groups with young people, rather to buy new clothes than to wash them. So encouraging reuse is an important element. A basis for reuse is separate collection. We are expecting full separate collection for textile waste within the next 5 years. And we are expecting concrete, solid targets for reuse and recycling for textile waste also coming soon. What are the activities which are addressed in these directives? I mean, it's clear from the numbers we have seen that the choice of materials is of utmost importance. And amongst the materials which are used in the future, we want to see more and more recycled material. So far, thinking about the picture, about the image Ellen MacArthur Foundation has painted for us, the use of recycled material is very small. So in order to direct the choice of materials, we will see regulations, we will see public procurement going into this direction, we will see more eco-labeling and more standards setting a framework for using recycled materials. Extended producer responsibility is an element. We will expect logistics to take back products so that they are returned in a way so that they can be recycled, what is not the case at present. We will see circular business models. We will discuss quite a few of them tomorrow, what is actually already used and what can we expect in terms of renting, in terms of leasing, in terms of deposits and so on. We will see more and more communication. I will show you a few examples. What initiatives are up for awareness raising, to informing the clients about the potential for reusing, repairing, exchanging, sharing clothing. And one element, because it's very relevant also from our observations in working with industries, which is waste and overproduction in this sector, because by far not everything that is produced, at least in Europe, is actually sold. And at least this waste should be avoided by planning, by involving the client in business planning and so on. So these are a few recommendations. Business models need to be changed. Sounds a little bit abstract at this point. I will explain this in more details. The supporting of leasing, sharing platforms, take back infrastructure, reselling product. The thrift store, the second-hand store is an element in this, and so on. Green public procurement as an element, that the public procurement leads by example. In all the public tendering also, there should be a focus on green, on recycled, on circular production. Recycling and reuse. requires a few prerequisites. One of them, as we have already discussed, is to collect textiles separately. In Europe, by the end of 2025, there shall be a system in place to guarantee that all used clothing is collected separately. And second issue, to ensure that all these textiles which are collected separately are not incinerated or landfilled, but that they are either reused or that they are reprocessed so that the fibers are again opened or carded, processed into yarn, into new textiles. So these are the recommendations. And to show that this is now, as Ms. Alio has said, a very integral approach, let's have a look at this slide, because this disc actually shows us the portfolios of activities which are now being promoted. If we start on the left-hand side, we are starting with materials. Safe materials means to avoid any substances of concern. We have a long list of these. It starts with POPs and ends with chromium. This means education for designers, which materials to use. This means to spur the demand for sustainable fibers, for biodegradable fibers, for fibers with a biogenic background. This is the materials sector of this disc. Collection, reuse, waste prevention is the second important sector. This means waste prevention. And this now addresses us directly as companies producing garments, as companies producing apparel, to minimize waste from production and to recycle production waste, because at this stage, this is quite easy. We have separated, single, clearly identified materials which can be recycled into the process. This is much more difficult. We have a mix of fibers in post-consumer textile waste. So waste prevention on the company level is a focus. Waste separation and collection, we have already discussed. It's almost impossible to recycle mixed textile waste, which is combined with other materials which we have to clean, which we have to separate. The fiber becomes so expensive when recycling this mixed waste that it's not worth the while. Important focus is then longer use. I will show you in a minute an example how a big chain, a big fashion chain is picking up this already. Sharing is one thing people are putting much expectations on. All this needs to be supported on the policy level by measures to educate, to change behavior. So this is basically what we are talking about. So circular economy in the textile sector is not a singular activity anymore, but it's an integral approach, touching design, touching materials, touching production, touching collection, and finally recycling with one approach. Circular Economy Action Plan, the Green Deal, linking to what we have heard already. We know that textiles are the fourth highest pressure category for the use of primary raw materials. So we want circular recycling there. At the moment, it's estimated that less than 1% of all textiles worldwide are recycled. So we definitely want to increase these numbers. And out of these, we expect not only relief for the environment, less use of resources, but we expect strengthening industrial competitiveness out of this by reducing on the long run also the effort for materials. Prerequisite for we have already touched this topic, separate collection to keep textile waste separate and identifiable is an important precondition for any recycling activities. The more we mix fibers, the more we mix materials, the more effort it is afterwards to separate them again, the more expensive it is, less probable it is that it will be actually done. So what we will see in Europe, and I'm sure likewise in Ukraine in the next years, is more collection schemes, collection campaigns, containers in the public so that textile waste can be collected in a cleaner, in a better way to support all these recycling activities. I promised you to show what people are already doing. If you go to H&M's webpage now, you will find their autumn collection. And within the autumn collection, you will find these dresses, which are advertised by slogans like, "We make clothing to last." This shall suggest, in this case to young people, that clothes can be worn more than one season. You can keep the clothes, you can clean the clothes, you can reuse them. You even might want to share them with your peers, with your fellows. And H&M is taking this slogan into their marketing campaign. They are giving this EU strategy a voice already because they see what is necessary and they see what is required. Another slogan which relates to the picture on the right-hand side, we use recycled polyester, and they are almost part of it from our production waste because they are reprocessing it, and polyester can be reprocessed nicely, and part from PET bottles. Because as of now, it's true that most of the polyester actually, which is recycled, comes from recycling PET bottles and not from recycling production waste or garments, but this shall change also in the future. So H&M is giving the circular economy strategy a voice by saying we promote long life of our products and we promote recycling of materials. These are two key elements of the EU strategy, which is already resonating with one of the biggest fashion chains in Europe. Supporting is the EU eco-label, which is sort of picking up, giving direction, giving a framework for what is considered eco for textiles, for garments. Clear we don't want dangerous substances. This relates, for example, to azo dyes. For leather, we shall be careful about water, because tanning consumes lots of water, of course. Certain emissions like VOCs and so on shall be minimized. Materials of concern like PCB, TCB, VOCs, azo dyes already mentioned, shall be eliminated, at least from textiles wearing the eco-label. There are recommendations regarding energy consumption and packaging, because these are also really relevant topics when talking about circular textiles, when talking about green textiles. Well, this was in a nutshell what the European Commission is asking us in the near future. Now, let's explore, before we go into our exercises, let's explore a little bit the basics. We will dig into more details later on for the footwear sector and for the garment sector. This next 10-15 minutes is just an introduction to all the basic technologies which are now used when recycling footwear or garments. Let me start by one fundamental thing. When we talk about recycling footwear or garment, we're basically talking about 3 steps. Because at first, we need to separate the fabric, the shoe, into the fibers out of which it's made, or into particles of the materials, like the ethyl vinyl acetate, like the polyurethane, like the rubber. Because as such, it's not valuable. We need to grind it in order to be able to separate it so that it becomes a useful material again. Second step, almost inevitably, is the sorting of materials and the cleaning. This is a step which adds to the cost of recycling. So it always should be our intention to minimize the requirement for this step. If we manage to receive very clean fibers, ideally of one color only, separation and sorting is much easier as compared to the situation when we receive a big mix. And in the third step then, we combine the particles or the fibers again to the product, to the new product which we want to have. These 3 classes of activities are basically also the framework for what we are going to discuss now. Let's start with fabrics. How can we separate fibers out of fabrics, out of blends, out of mixtures? We need to open the fabric and we need to card them, to prepare them for spinning them into yarn again. This picture shows the procedure. These cards are the basic machinery which we need to open the fibers, to disaggregate the fibers, and to prepare the bands for spinning again. Basic technology. Usually not a small-scale technology. This is one thing we need to discuss with all these technologies, where very rarely they are fit to handle small volumes of material. So when we discuss about recycling production waste and post-consumer waste, we are probably talking at the same stage about cooperation of industries simply to have bigger volumes. Thermoplasts like polyurethane and so on can be very nicely milled, like in two-roll mills, to very small particles, to powders of less than 200 microns diameter. And this powder then can be used as a filler in new polyurethane foam. I will show you later on. So in principle, it is possible to recycle many a production waste. Example here is for polyurethane, where we have production waste like from flashes on the molds, if the molds do not seal tight. If we stamp, if we press soles out of slabs, we have cut-off waste. And these cut-off waste, these flashes, these runners can be shredded, can be ground, and can be reused up to, depending on the polyol which is used, 15, even 20, 25%. So basically, production waste from thermoplasts can be recycled. Question is whether it's profitable. I will show you a few slides regarding this. In the industries supplying car makers, these board making, for example, by compression molding, is an established technology. These particles which we have got from grinding waste, for example, polyurethane, we can press if we exert enough temperature and pressure without additional binders or with binders. Also, to these materials, we can reuse 10–15% of material. Injection molding is a third technology. The particles, a little bit coarser particles, are fed into these screws. They are plastified and can form new parts. This applies to particles which are clean enough so that they do not require sorting. If we have to sort, we have basically two technologies. On the left-hand side, we see an air cascade, where in counter flow towards upflowing air, gravity separates the lighter particles, the fluff, from the heavier ones. And very similar principle is the vibrating air table, where by the angle of the sieve, airflow and vibration, again, we can separate materials of different density. So basically, we can separate lots of things, but at the expense of an effort. We will discuss this in more detail later on. A very important process, very elaborated and very common in the last years, is this repolymerization. If it's applied to bottles, it's called PET-to-PET, else it's re-PET. Mostly the application is to take PET bottles, to remove the labels, to crush them, to clean the flakes by washing, and sometimes also by UV sterilization, and then to melt them again. so that they can form new bed granules, which then can be processed into yarn for clothing or into new bed bottles. These bed-to-bed bottles has become a very established technology, like for mineral water. We have 2 big plants here in Austria, each processing about 20,000 tons of PET bottles per year. So this technology is out of its infancy and is well established and to some extent profitable. Let me explain this in a minute again. And then we have a lot of research going on and some practical applications in the field of chemical recycling. Chemical recycling means we dissolve the polymers again. This is mostly applied to cellulosic fibers, and we make new yarn out of the solution. The central technology in this respect, from the Austrian perspective, is lyocell from Lenzing in Upper Austria, where they dissolve production waste and make new lyocell fiber out of waste. The beauty is when using NMNO, N-methylmorpholine N-oxide, as a solvent, PET and other fibers are not dissolved, so you can separate the cellulosic fibers from other fibers. And there is a lot of research in this respect going on. Last resource, not so much established with us, is pyrolysis, where you split the longer chains into monomers or oligomers and again polymerize the fibers you want to have. Now, in summary, what we have discussed now for footwear recycling, because this will be the next presentation then after the exercise, what are the options which we have? From left to right, left the ones we want to discontinue, on the right-hand side, then the ones we want to see more and more in the future. We are talking here in this example about shoes, which are not longer required by the consumers. Traditional ways to dispose of them in a landfill. This is not what we want. The materials are lost and they are a burden to the environment. We have incineration, gasification as the second option. If we recover energy from this process, there is a benefit, but we will also discuss this later today. It comes at a cost, because if we incinerate a mix of materials, we have to expect toxic emissions, and we have to treat the exhaust gases at a quite considerable effort. So this is, again, incineration, gasification is not the way we want to follow. Third approach, which is mentioned very strongly in the circular economy strategy, is reuse, is remanufacture, which basically means, in this case, to give shoes a second life, either by repairing, reusing them, or, as is the more common practice, by exporting the shoes to less developed nations. So this is also not what we want to continue on the long run. And then actual honest recycling kicks in, and this is what we want to promote in the future, and this is where our efforts are directed. And we have discussed already the basics of how this can work. Fragmentation by grinding the materials to small particles, by sorting them, and then by reprocessing the rubber, the fiber, the EVA, whatever is the product. This we will discuss in a minute. Now, what is the problem in the last years, actually the last 2 years, with these recycling activities? Let's look at the right-hand side first. This is the benefit. Comparing, for example, virgin in red polyester fiber with recycled one, there is a clear economic benefit. Recycled polyester comes at half the CO2 emissions as compared to virgin polyester. This is the ecological perspective, which is very much in favor of recycling. And this is true also for PET, for poly bags, and so on and so on. So ecologically beneficial. Now let's have a look at the business aspect. And as we would have expected, until the beginning of next year, on the European markets, recycled PET was cheaper by about 10–15% than virgin material. That's the world as we would have expected it to work. The recycled material is a little bit more difficult to process, but it's cheaper. Since June last year, this simple logic doesn't work anymore. And actually the major obstacle to recycling all sorts of plastics and fibers and so on at present is that in many cases, not in all cases, but in many cases, the virgin material now is a little bit cheaper than the recycled one. And this is really slowing down recycling activities a lot. And we think this will change again, but reasons for this, we are not quite sure. Maybe you have ideas, but apparently last summer, demand changed a little bit and there was an oversupply of virgin fibers and virgin plastics, causing prices to drop. And in recycling, you only have a certain learning curve and you can reduce recycling cost only to some extent. So right now we see this economic imbalance that actually for many materials it's at the moment cheaper to use virgin materials than to use recycled ones. This is something which is important to know when the question is raised, why are these recycling technologies? Because there exist lots of technologies and basically you can recycle many or most of the materials. When the question raises, why is recycling taking off so slowly in Europe, and why are we already a little bit behind schedule, and why we are not fully embracing the idea of going circular? Yeah. What is the conclusion? Conclusion is a very much common sense conclusion from our perspective. It's coming back to the established waste reduction hierarchy. The most preferred option is prevention. And from a perspective of a production company, this means to prevent waste in the first place by applying resource efficient cleaner production measures inside the industry, which means optimizing cutting, reducing flash, reducing runners, embracing all these technologies, minimize packaging, reusing packaging, recycling immediately in the industry by grinding runners, mixing them back into the virgin materials and so on. So starting at the prevention to keep the effort for recycling as low as possible, to reduce the consumption of material in the first place. And then, of course, use all the applicable recycling options, of course, considering economy. For us, this means now, and this is then the focus of the next 2 days, to explore a little bit the potential of material choice. I will be more clear on this in a minute. To explore all the potentials the production process has for minimization of waste in the first place, and then talking about reusing production waste where possible in the industry or in a cooperative effort of similar industries or the industries in the region. This approach has the highest leverage effect and usually the best economy. Yeah. Do you have questions regarding this brief presentation, regarding the background, regarding what Europe has set as the political framework for the next 10 years with regard to garments, with regard to footwear, which basically means no dumping, no incineration anymore, but material recycling of all the fibers, of all the materials, plus the basic technologies to separate fibers, to mill, to grind, to powder, and to recycle recycling materials as a substitute for virgin materials. Do you have any questions? What is your experience in your industries? Because from the participant list, I see that about half of the participants represent industries, represent footwear, garment industries. What do you do with your waste at the moment? Do you want to share your experiences at this point before we jump into the exercise?
Can I ask Speaker Jonathan, can I ask a question to you? Maybe my colleague will be interested too. Can you hear me?
Yes, I can hear you.
So can you tell me how Ukrainian companies can use the technologies from your presentation if they're not in Ukraine now? So how can we franchise them or just bring them for Ukrainian companies into the change of production if they're not in a market here because there's legislation, all that paperwork? So this kind of question.
Yes, I have discussed this with Andre when preparing this presentation. Let's do this step by step. At first now, we discuss technology, potential options and so on. Then we discuss with you what might be applicable because of the materials you're using, because of the quantities you're using, so that we get a clearer picture. And then you will see then in the next presentations quite a few companies who can supply these technologies without any preference. We need to discuss then what is the best appropriate technology for the for each case, and then we start the discussion. Andrei will take care of the Ukrainian side. We can take care of the Austrian, German, Italian side to start this process step by step, to clearly outline the demand, to also do some, let's say, preliminary calculations to see what is really viable, what is really meaningful, and then to match make and then solve practical problems in the transfer of technology. Was that an answer? So let's start by exploring, and then we select what has the best potential, and then we match make, and then we do the implementation. Unless you have already a dedicated demand, then maybe we can discuss this. Okay, let's leave it like that. The chat is open. Please put your questions there. Everything we shall follow up. Please send me an email or be so kind and discuss with Andrei, because Andrei will bundle all the requests and demands, and we will then continue follow up all these practical steps. Okay. What I want to do with you now is exactly this first step when selecting a technology. We are going to use one tool which is called waste mapping. I'm sure most of you, or many of you, have used this already. It's a very simple tool. We start from the layout of a company. We observe what wastes are generated, and we mark on the layout where we observe the respective waste. So basically, we take a layout, a flow map of our enterprise, and we mark, starting here from the offices. We have energy here, we have organic waste here, we have paper waste here. And then we continue through the departments, and for the production area, this is a galvanizing plant now, we mark, well, we have chemicals here, we have chemical waste here, we have chemical waste here, we have product waste here, because we have material which over expire, which are produced in excess and so on. And we have packaging waste here. So these waste maps basically are built during a walkthrough. We are looking for waste, we are identifying waste, we are marking on the map where we observe the waste. We try during this process to identify the source. So we ask, why is this waste here? Why is it generated? And we make a note on this. And of course, because this we will need to set priorities then for which wastes we deal with, for which wastes we will continue working on options to reduce waste. We estimate the value of the waste which we observe there. So waste mapping basically is building an inventory. Where in our factory do we see waste associated to the source of waste and the estimated value or quantity at this stage. We take a map, a flow map as the starting point. We indicate the departments, the machines, and we clearly mark where we observe which waste fractions. And this legend here is an example. We can make our own legend so that we show where do we observe packaging material, other plastics, raw materials. In our case, fabrics, plastic materials, and so on. Next technical topic, and I will condense my presentation a little bit. We are continuing basically from the example we have worked on, now with the focus on footwear, recycling options for materials commonly used in footwear, and a few thoughts regarding the feasibility. When I say feasibility, we have feasibility in the current situation with all the framework, with all the boundary conditions, but this feasibility also should lead us into the future to be aware of these options when things change, when production increases, when prices maybe change again because the demand picks up again and so on. So let's focus on the options and let's keep them in mind then for our consideration. I don't have to tell you how a shoe is produced. I just want to highlight a few things. Some of the things Ivan and Andre have already touched. This shoemaking process for us is relevant from the perspective of materials used, waste generated, and potential to minimize and recycle. It is obvious that during the design phase, we have most of potential impact on waste, on materials, and this we definitely should use. This is one of the first priorities the EU mentions in the Green Deal, in the circular economy plan regarding textiles. Proper design, awareness regarding materials, a proper selection is a key issue. This also relates to the development of the shoe then when the patterns is drawn, when the sequence of activities is set up and so on. Then we order materials. We are all aware of problems in supply chains in these days. We will have later on a few thoughts regarding renewable materials, recycled materials as raw materials at this stage. In repair, I think we agree, it was mentioned by Katharina. Cutting is a major generator of waste. We'll share a few thoughts what we can do maybe to reduce cutting waste. Sewing, blasting, assembling, outsoles, materials used there are topics. So this is basically the process. One issue in footwear is the multitude, is the variety of materials used. In a shoe, we can find easily 30 materials, which all serve their purpose, which are all used for a specific function, but in combination make recycling very difficult because we have to separate all these materials then when we want to recycle a shoe. Same logic when we want to recycle waste inside the company. Separation is the first key to keep the fractions of waste clean. Materials we are talking about these days is cotton, of course, polyester. It's most of the fabric we are using is polyester, polyurethane, which is soles, midsoles, wool. I will show a nice example. Leather, also metal parts in some functions, and in the soles then also the rubber, maybe PVC still, for sure EVA. These will be the main materials we will be using, and these are also the materials we will be discussing now regarding potential processes for their recycling, their applicability, and their economy. This is just a breakdown. It's from the International Organization Leather Panel, which you are probably familiar with. If there was something like a typical or an average shoe on this planet, it would consist 1/4 leather, more or less a little bit less polyurethane, rubber, EVA, and then other materials. So this, of course, gives the priorities now for us. Before we start with the recycling operations, let's briefly discuss where do we generate waste. This is building on your nice waste maps. Why do we generate waste there? And then in the next slides, what commonly can you do to reduce waste to a certain extent? In footwear, it's almost impossible to work with zero waste, but at least we can do something to reduce. We have the outsole. Here we have the issue of molding. When the mold doesn't fit tight, we have flash, which becomes waste or can be recycled. If it's not burned, if it's collected separately, it can be recycled. Likewise, the carrots, the runners, where the material enters the molds, this becomes waste. This can be considerable waste. We have numbers of 15, 20% in some factories. This can be significantly reduced. Sole preparation before cementing is the buffing, the dust. With components, accessories when treeing the shoes, main issue to my experience is unused old stock, which when it's not fashionable anymore, when it cannot be used anymore, is discarded. Materials and packaging waste. Okay, we have discussed this. There will be paper, there will be cardboard, there will be shrink wrap, plastic wrapping. We might have some answers to this, at least to reduce. And we will use chemicals. Cement was mentioned. We will use solvents also. In maintenance in the factory, we will have lubrication oil, hydraulic oil. We will have general workshop rubbish. This is from an old project. It's probably not true anymore, but what was done at this stage was an inventory of waste and the result, the breakdown of waste we see here. Leather waste was 4% of total waste. Outsole and midsole was almost a third of the waste. And then there was also waste from fabric, from cutting, and some packaging waste. So this sets the framework when we set priorities then and start working. Now just briefly summarizing potential options which more or less apply or which many times apply. When cutting for the uppers and for the lining, leather, textile coated fabrics, we will have cutting waste. A little bit more in cutting leather, because leather is a natural material, it's not uniform. We need to optimize the cutting pattern, but also regarding the quality of the leather. Not every part of the leather can be used for everything. So generally there will be waste, cutting waste of 25 to maybe 35% of a hide. Of course, this is a matter of optimization between labor cost and material cost. And when labor is dear, maybe you allow a little bit more material waste than when labor is not so dear. But usually by motivating the operators, by incentivizing high yield and so on, a few 2-3% or so reduction of cutting waste is possible. Talking about the materials for the outsole, can be rubber, PU, EVA. It depends a bit on the injection technique, how much waste in the form of flash, carrots, purges, when cleaning, when changing material is generated. Here we should make sure that the molds are in good condition, are closing tight. Also, of course, the design and the selection of the mold, I will show an example in a minute, have an impact on the amount of waste which is generated at this stage. And by proper maintenance, by proper selection of the injection technology, a few percent of waste can be reduced at this stage. Cutting again, we have when we cut the board, be it a leather board, cellulose board, polyethylene, or the leather for the insole. Here, this should be mentioned also for the cutting of the uppers. Automatic cutting by water laser with computer-based optimization, pattern optimization, combined with video control of the leather, identifying defects and so on, can reduce cutoffs, cuttings. This is probably applicable for the really big factories. I'm skipping the in-soak or the reinforcement. Roughing dust before cementing, if possible, should be selected dry. If no metal is present, this is possible, because if we use water in cleaning the exhaust gas, sludge will be the result. Sludge then has to be dealt with, whereas if we have dry dust, it's easier to handle. Regarding the other parts of a shoe, like heels, eyelets, laces, threads, fasteners, we will see the problem that there is a cycle in fashion, and these parts do not over-expire like food, but yet they cannot be sold anymore and therefore become waste. Here, careful stock management, just-in-time ordering, or an agreement with your trader that he takes back material you cannot use and sells it elsewhere can help to reduce waste. These were a little bit more. Lacquers when finishing, this is pretty much to the attention of the operator, whether there is overspray, whether there is overuse. Petroleum spirit solvents for cleaning. There we have the option. Ivan mentioned chemical leasing, that all this gluing, cementing is more or less externalized, and you pay per, how is it called in this case? You pay per shoe, basically. Another option is really to get into the process, to understand the process, to optimize spray guns, spray pressures, to use water-based adhesives, to minimize the cleaning effort. And with the solvents which you use for cleaning, which is MEK or other solvents, that you recover them and redistill them for reuse. This is an option actually which is feasible for many companies. Now, when we jump into recycling, after having studied all the minimization potential, we're talking about technology, yes. Greater material separation is always a prerequisite, and of course, technology should not interfere with processing time. This is something to consider then when selecting improved technology. When we do recycling, we will have options of recycling internally, but for many recycling options, we need an external market. We need a colleague or another company who receives our waste material as a substitute for virgin material. So we need to network, we need to aggregate in a cluster, in an industrial park, whatever. And of course, last but not least, all the ideas, all the options will have to pass the screen of economic viability. So we need to have an idea of cost, and cost with all these technologies depends a lot on the scale of operations. Small scale recycling usually specifically is much more expensive than if we have a proper scale, a proper mass. So also in this respect, cooperation might be key. Let's run through the materials. Let's discuss briefly what can be recycled, using which technologies, and what is more or less the range where it makes sense. EVA, used for soles, used for midsoles, basically can be recycled. However, at least to my knowledge, the rate of recycling generally is very low. In the companies which are left here in Austria, we could not find EVA recycling. Maybe during the discussion, you correct me whether you in Ukraine have a different situation in this respect. There is technology available, and we are seeing here two paths. One path is to collect the EVA waste, to shred it, to extrude it, and to receive then ingots which you can process further. This technology is commercially available. It's not so expensive. The approach I personally like more, or like in any case, is what is called runnerless EVA by King Steel, who is supplying many injection machines for EVA. It's like in injection molding, the hot runner system, where the material in the runner never solidifies and therefore does not become waste. This system applied in the footwear industry can reduce material consumption by 15%, benefit less material use, and there's no need to recycle because all these carrots and runners simply do not exist anymore. So something to consider, especially when buying new machines, and probably also when going for high volume production, this runnerless system. This is an example for this hot melt densification. On the left-hand side, we have these, basically it's an extruder where the shredded EVA is pushed through and can be turned either into this mass, which is then fed into a granulator, or processed, and this we see on the right-hand side in proper EVA sheets, which we then can use as a substitute for virgin material. So EVA basically either to avoid waste if possible, or it can be densified and reprocessed. Polyurethane, likewise. In this case, the technology which apparently is the most economic one is two rolls millers, which are simply two mills working against each other. We will see a few pictures in a minute, and they are capable of grinding polyurethane foam down to 200 microns or less. The smallest I know is 50 microns, so really a powder. And this powder then can be used basically like a filler for the next preparation of PU foam, to mix it to the polyol. About 20% reuse is the maximum possible. The thing is, the cost savings are not sensational because we need equipment. These are two examples here for these 2 mill grinders, two roller mills, these grinders you see in the upper pictures. And then we need a specific injection head, which mixes the powder into the flow of the polyol. This process adds about half €1 of cost per kilo to the material. So it's cost to replace or to use a new filler system. And in this case, this is Mobius, the Swiss company, which is focusing on PU recycling. So it's possible. It's also not commonly used, but it is used, this grinding of PU and adding it to virgin PU. This simple variant is used. A more sophisticated one is chemical recycling of polyurethane, where the scraps are ground, mixed with an alcohol. There is a glycolysis, and the recovered polyol is incorporated into the fresh polyol during production. This does operate at industrial scale and is economical, but in volumes of more than 1,000 tons a year, so some 4 or 5 tons per day. So if you have less waste than that, it's probably not the route to follow. For the ones who are interested, I put the names of a few applications. First one is a Dutch company, Retour Matras. This is not footwear actually, but mattresses. And Dow, the chemical company, and BASF, they offer these to their clients, but it's for bigger quantities. A little bit sophisticated is injection molding of polyurethane. This also works. You take scrap particles, you feed them into an extruder basically. The screw plastifies the PU and you can then in a die produce your parts. This is used but also a little bit in another industry, like in producing automotive parts. Yeah, there this technology is well established. But again, it's probably for bigger quantities. Now, let's jump to leather, recycling of leather. It's not a good idea to landfill leather because over time it will produce leachate. So you have to collect the leachate, you have to treat the leachate. In the European community, it's not allowed anymore because of the high content in carbon to put leather in the landfill. So we have to look for other options. Incineration I will discuss in a minute. This is an option with some caveats. Other options are to use leather to produce leather board. And if I understood correctly, this is done in the Ukraine. This is actually established over the last 15, 20 years from Brazil to Germany. The principle is to grind the leather to fibers and then together with a binder, which most commonly to my knowledge is latex, to mix the fiber, the latex, and to press boards out of this mix. And depending on the combination of leather, binder, plasticizer, probably your skills, you can create a product which comes very close to real leather if you want to, or which has this typical leatherboard construction if you want to use it for example, for the inlay in my bracelet for the watch or in my belt or whatever. The compound can be manufactured with up to 90% leather or probably even more. This is an example. This is Salamander. This is one of the companies in Germany who have pioneered this and who are still doing this for a variety of applications. They call it LEFA, which is Lederfaserstoff, which is fibrous, compacted leather material, reconstituted leather. Yeah, this is established. If you have the quantities, if you have the market, this is maybe something to produce from leather waste. Leather can be used as fertilizer also. This works by dissolving in a strong acid and then precipitated the basically collagen with lime. Yeah, some people like this fertilizer, like for orchids. For regular purposes, the nitrogen content is low. And if we use chromium tanned leather, chromium can be a problem and you need to control the application. Leather also can be processed to gelatin and glue. Works nicely. Hide glue is a classical glue for musical instruments, for guitar, for violins, for construction of cabinets and so on. Issue is there is a lot of leather waste available from tanneries. So if you are a footwear company and want to get rid of your leather waste, you are in competition to really big suppliers. But maybe on a regional level, if somebody is processing leather to gelatin or glue, this might be an option to cooperate. Summary, and this is leading to the caveats. We will need specialized production equipment, which is probably not really our core business as a footwear company. The plants we have calculated are economically only at quantities of more than 2,000 tons per year, so roughly 10 tons of material per day. Yeah, if you're big enough, these might be options, or it might be an option in an area where there is a concentration of footwear companies with the same waste, with the same problems. Leatherboard and fertilizer have some commercial success, working on waste from the industry. Now, rubber is a classical material for soles. For some types of footwear, rubbers, the rubber can be put back into new shoe soles. I can show you an example in a minute. It's the economically viable recycling is from ground rubber. So we have to grind the rubber first, like in the example of the polyurethane, which we saw before, to basically a powder. Basically, we have three routes. We can use cryogenic by cryogenic grinding, by cooling the rubber using liquid nitrogen. Works very nicely. Problem is nitrogen is not cheap. Ambient or wet grinding then uses an air jet or a water jet in between rollers to do the grinding. Works also nicely. Your main application, we'll show an example also in a minute, is however not recycling into shoe soles, but mats, floor tiles, carpet undercushions. In Asia, a market has been established, and also in Germany there is a market now for powder, rubber powder, but this is mainly material from retreating tires, like for trucks, because there is still a big industry retreating tires, and when you cut the worn material from the tire, this rubber also needs processing, and this is available in huge quantities. I think I have an example also. This is a granulator. You see the knives and how they work on the rubber to cut it down to small pieces. And on the right-hand side, you have the scheme of cryogenic grinding, where you have this pre-cooler where liquid nitrogen cools down the rubber so that in the grinder it can be ground to this fine powder. Yeah, here we see some pictures from a German plant. It's called Kurzkarkassenhandel. You can look them up on the internet if you're interested. You see these mills here, again, these two roller mills, grinding down, in this case, the shavings from the tires to this fine powder. And on the right hand side, you will recognize the logo of the rubber sole provider who uses, I think, 15 or 20% of this recycled rubber powder in the production. Again, the last process I showed you is more applicable to big volumes. To counter this, in Germany, there is a development which still has to, let's say, penetrate the market, which is a specific type of mill, which is actually a mixture of an extruder and a mill. That's why they call it reactruder. And this can grind vulcanized rubber. And this is designed for smaller quantities like 15 to 100 kilograms per hour. So this is applicable also on the level of individual factories as an option to regrind rubber. To what I know, it's beyond the pilot stage, but it's still not widely applied. Maybe one or the other of you know more about this, but maybe this would be one of the technologies to follow up in more detail. Now, this was always now dealing with. Now, what can we do when we have mixtures, or the worst mixture, as we discussed initially, a ready-made shoe consisting of 20, 30 different materials. This is a lab installation to grind down sneakers and to separate the different fractions of materials. This is possible using the air cascade you see in the center of the picture and this air table. You maybe remember the cross sections which we had in the first presentation. On the right hand side, you see a scheme provided by the company SOX, which is applying this lab process on a pilot scale. The project was developed with money from the European Commission, which supports all these activities a lot over the last years, and it also still needs, let's say, the last stage for full upscaling for market. Reason being, applications of the products of the grinding and separation. The rubber powder can be reintegrated into footwear outsole. Tests have been finalized, and now there are pilot runs to incorporate the rubber powder from the recycling of whole shoes into outsole, into outsoles. The foam fraction, for using this, they are using the route Nike is also taking with its Nike Grind process where they basically produce running tracks and such installations. And leather, can be reprocessed. The thing is just we have the competition of these other leather type materials which we have just discussed. So the application is still to be found. I was mentioning Nike Grind. Nike does this with part of the shoes are returned to them. They process them with a very similar process, and there is an annual competition of products which can be made then out of the granulate. And on the right hand side you see a few of the best products, which are yoga mats, which is flooring, which is handles for climbing, indoor climbing installations, and so on. Summary: materials are difficult to separate. They potentially can be recycled, in particular the thermoplasts, EVA, PU. Regarding recycling of a whole shoe, no plant is operational now, according to our knowledge, because it's not so easy to meet the technical requirements of virgin materials, and simply the cost of these recycling operations is considerable. We are talking about 60 to 100 euros per. Now, last thing is incineration, which is the most common route today. What is the problem with incineration? The calorific value of all these materials is nice. This is around 17 megajoules. This is good. Problem is, as soon as we have PVC in the mix, we have the chlorine, which promotes the formation of dioxins and furans in the exhaust gas of the incineration plant. As soon as we have chromium, leather, chromium-10 leather, it will be transformed into chromium-6, which is a problem. So following these thoughts, we need to treat waste gases sincerely, and this is no technical problem, but this is expensive. We have here the installation of a gas treatment train for I think it's a Swiss rotary kiln incinerator for all these materials. Yeah, it's expensive. Recycling solvents, I was mentioning, this is a small option which is applicable a lot. Small recycling units are available. These are basically stills distillation units to redistill the material, the solvent. And then maybe for your attention, there is a lot of information provided by the European community. I'm just mentioning this webpage, Circular EU, with a specific section on textiles, apparel, leather, basically giving a lot of similar information like we're discussing, much more information on material selection, case studies, examples for recycling. We are continuing today with our focus on recycling for the footwear and garment industry. Garment industry is now the focus for the next 2 hours. Again, we are following these like yesterday. I will try to be concise and brief in the presentations. First ones on materials used in textiles and garments, recycling options for these specific materials, and also a few thoughts about feasibility. Then we will together work in groups on exercises. I'm really challenging your experience also in selecting equipment for recycling, in selecting recycling routes. Maybe we can share what has worked with you in the past and what could be the future. And the second presentation will exactly focus on this. From what the European Commission is telling us and from collecting practical examples, how pioneers in the sector address the issues of a circular economy, new business model, and so on. I will present a few cases, and then together we will explore what this could mean for us, whether there are one or the other ideas of getting our products back, recycling the products, ideas for cooperative approaches, following what is shown in the case studies. So without much further ado, our first topic for today is the garment sector, materials used there, opportunities for recycling these materials. In this slide, we show the beauty of the sector, but also the main problem for recycling. When talking about fibers used in the textiles sector, used in my shirt, in my pullover, in my jacket, we will find quite a few fibers which might be there individually or in combination to serve certain purposes, to provide certain appearance, to provide a function. We use mixes of these fibers, and these fibers could be natural fibers, animal fibers like wool, plant fibers like cotton, but also can be artificial ones, man-made fibers, which have a natural background, like in the old process, cellulosic fibers like viscoses, with the new processes, with the new solvent now, lyocell or modal, or other synthetic fibers, other polymers, nylon, polyester, acrylic fibers, and so on. And depending on what functions the textiles shall provide in garment, in footwear, we will use different ones, selected ones, or mixes, blends. Process, I don't have to repeat in detail. We are all familiar with how fabrics are made, starting from the fiber, spinning, then combining the fibers to a fabric or a non-woven, processing it, dyeing, finishing. That's where chemicals come in. That's also where energy consumption becomes an important point. And then the subsector we are representing here mostly today, cutting and sewing to get the final product. Now, this is actually not the message I would like to share, but this is the message. In this complex combination of processes now, what are recycling paths, ways of recovering material can we think of, which ones are practical, which ones are used already today, and which ones are the ones we will have a closer look at in the future. Now, maybe we resort to the right chart here, because this is in the tradition of all these roadmaps of the Ellen MacArthur Foundation, showing where these recycling paths are. There are small recycling paths around the garment producer. Garment producer can recycle production waste, and the most of the recycling paths actually start at the user, start with the used clothing at the end of its useful life, and traditionally they end up in landfilling or in incineration. We do have some recycling. I will show a few numbers in a minute, which lead to either reusing clothing or to downgrading the materials to rags, insulation materials, and so on. And this is now exactly where we want to become better in the future, by appreciating the value of fibers and introducing them again into the production process, which is not without difficulties. In the textile sector, we also use some recycled materials, which is mainly PET from bottles. This is at present a few percent of the total fiber material. This shall be increased also in the future. We will discuss this at length in a few minutes. And the last point, here we are where we started yesterday, is, and this is also involving now very much again the garment producer, new business models, as this is called, new ways of selling, sharing, selling again. Clothing is expected to have a major impact on making garments last longer and getting them back at the end of their useful life. So this is basically what we are talking about. And the message I want to send with these two pictures actually is, when we are talking about closing cycles, circular economy for garments, for fabrics, for fibers, it's a complex approach which is required, because the solution might be opening and cutting waste from the factory to reuse the fibers in a fully integrated plant. But the solutions might lay elsewhere also. And this complex integral picture shall guide us not only today, but also help us in our thinking in identifying appropriate solutions. Now, coming back to textile recycling, what are our options in a nutshell? First option, of course, and this is gaining ground more and more at present, at least in Europe. It's almost becoming a subsector of fashion, at least with the young people, is second-hand clothing. Believe it or not, in a city like Graz with 300,000 inhabitants, you will find 12 stores at the moment selling second-hand clothing, and they are doing well. And they are doing well. They also did well before we had all these crises, which also has an economic impact. But really, for young people, it's becoming a statement towards the excessive use of materials, energy, and so on, to wear used clothing. Nice clothing, of course, repaired clothing, which looks nice, but second-hand clothing. Now, this is one aspect. Second option we have is mechanical recycling. You probably remember from yesterday these processes to open fabric, to card fabric, to spin again yarn from fabrics. We will discuss these fabrics to fiber today. For thermoplastic materials, we can think about remelting. And remelting is leading us already to chemical recycling. Several processes, which we also will discuss, not so much in detail, but touch them. How to recycle fiber material chemically, with all the advantages which this has and the drawbacks. And the last one for degradable fibers is composting, but this is here just for to make the table complete. Now, just in brief, this is what you would see in 12 places in Graz. We have, I think, some 30, 40 in Vienna. Shops where garments, which are donated basically by their former owners, are sold. More than half of the shops are charities, actually. But more than a third of these shops are doing this professionally on a commercial basis. They focus on vintage clothing, they focus on famous designer brands, but this has become a relevant part of the fashion which is sold, which is good for long life of products, which helps to reduce waste from this perspective. Now, recovery of fibers. A fabric is a complex aggregate of fibers. When we want to reuse the fiber to make new fabric, we at first have to disintegrate the fabric, which is done by cutting, by opening the fibers, and then by machines like the ones I showed yesterday, or this one. This is a more this is an older boy for carding cotton in this case, which is used now for carding used materials. The fibers we reclaim, according to the experiences we have collected, are usually shorter than 10 millimeters. One problem we have to be aware of is the generation of dust from the processes. There will be some fabrics which we cannot use, so we have to have some pre-sorting. And the main issue actually is the blend of different fibers, natural ones, polymers, and also of colors. So in any case, we need some pre-sorting, we need reliable partners in doing so. And this is bringing me, because you will ask the question, who is doing that? We have specialized companies here. Almost no textile company is doing it for themselves, not the garment companies and not the textile mills, but there usually are in Austria, not anymore, but in Germany, there are specialized companies who collect textile waste with the priority, of course, of production companies, because as we discussed yesterday with Ivan, reliability, reliable quality is an issue in this. So they are collecting these wastes and they are reprocessing them to yarns, which are used then for, let's say, second level qualities mainly. The classical example is the carpet industry, but recently there are also higher qualities available. In Germany, according to the numbers we got at present, however, 95% of recycled fibers goes to non-wovens mostly. Fiber, this is how it is called when we get production waste in the form of fabrics. We have to open it, we have to cut it. This is again taking us back to the machine which we have just seen. Benefit, it's a quite simple mechanical process. There is a market. We will not get rich on recycling fibers mechanically only. Added value is low, which means, in other words, that you need to concentrate somewhere. It's rarely economically viable to do it for yourself with low quantities. That's the reason why we have specialists collecting larger quantities from different mills, from different garment companies to process them together. Recycling of thermoplastic polymers works by melting and reprocessing. I will show the according machines in a minute. Fiber to fiber is commonly not directly viable. I will show an example that in some cases it is viable in a minute, because textiles contain in the first place a fiber mix, which we somehow have to separate before we can produce new fibers. And textiles will come in all kinds of shades by different dyes, using different finishing agents, which will make the direct recycling difficult. Bottle to fiber is actually what is the basis for most of the PET recycling, because you will know that most of the recycled PET fiber actually which we use does not come from textile waste or garments, but from PET bottles, from the water bottles which we use and collect. For remelting, we are back to this extrusion process where thermoplastic polymers basically are turned to resin pellets again. So they are exerted to temperature and to shear forces, and they are compacted again into pellets, and these pellets are then processed again, mostly not to fibers, but to extruded items like pipes, tubes, fans, window frames, where a clear color, where 100% identical properties are not so important. That's actually the way most of the thermoplasts go. A special role is played by polyester, which is a very common material. Almost half of the world's clothing at present is made of polyesters. This is why basically many of the major apparel and retail companies are cooperating, and they have plans how they together can increase the share of recycled polyester. At the moment, still a lot is, as I started to explain, is bottles, but there are also plans to recycle more polyester from fibers. Yeah, one small remark why it's much easier to say water bottles or soda bottles for fibers is just 5 1-liter bottles for mineral water are enough to produce a functional t-shirt. And this bottle to fiber is a quite straightforward process. Most of the water bottles are clear, so this process route is much easier than recycling dyed and finished fibers from papers. In the case of polyester-based textiles, which mainly applies now to factory waste, to cutting waste and so on, which is clearly identified, where we know what the fibers are, what the finishing is, the garments are, or the material, the fabric is shredded and then granulated to give these chips, which are subsequently then melted and turned into fibers. Now, this is turning us to chemical recycling. I have to say, as an initial remark, these technologies are very well developed. At present, they are applied in some niches. There are some companies dedicated to this, but chemical recycling is nothing for the small scale anymore. What are we doing in chemical recycling? Basically, we are unzipping long polymer chains. We are cutting them ideally into their initial constituents so that we can recombine them again. Mostly this works by adding a solvent, which can be as straightforward as water, steam, to break up the chains. Can be alcohol, which is actually at present the most common process, to use D-ethylene glycol as a solvent. We will touch this in a minute. The first process which has industrial relevance is the EcoCircle process that was developed already 15 years ago. A Japanese company by the name of Deijin. They have joint ventures in the meantime all over the world doing this chemical recycling, which basically decomposes polyester by adding glycol to break down the polyester. The beauty here is that we selectively dissolve the polyester, and other fibers are not touched. So this solves the problem to some extent of sorting the fibers. Ecological benefit is by recovering the fibers, we save about 80% of carbon emissions, which are else related to producing the virgin fiber. H&M, for example, is cooperating with Deijin, and they have started recovering fibers by chemical recycling, and they want to increase the share of fibers which they are going to recycle in a chemical way. Another approach, and I'm taking you back to Austria now, to Lenzing, producer of cellulosic fibers. In the past, it used to be the viscose, viscose materials. Process was changed because of the solvent. process is now modal or tensile. Principle is the same. We take a pulp, we extract the cellulosic material, we turn it into a fiber, which is then considered a more or less natural fiber. We try to get the wood from sustainably managed forests. The fiber, spent fiber, cut offs, textiles coming back after use, can be introduced in this process. So a closed process is possible. And again, we have the same benefit like in the EcoCircle process of dating. This process is more or less selective. So in this case, we only extract the cellulosic fiber, and all the rest remains unresolved. This tensile is, or refibra, the recycling of fibers, is gaining more and more ground. The process is accepted very well. I don't know, maybe one or the other of you is using these fibers. Many renowned sports brands like Patagonia, Adidas are using these fibers to some extent. Polyamide also can be recycled. Polyamide 6, very easy with superheated steam. Of course, provided we have separate polyamide which can be used for this process. The process is called ECONYL, sorry. And one of the products you probably would not have expected to see here in a presentation on recycling is this nice Gucci bag, because also a brand like Gucci has to make a statement about this trend of recycling. So they have a few bags in their collection which are actually made from recycled materials, and this is an example. Maybe the ladies know the name of this handbag. I'm not so in this part of fashion. Now, to summarize, what are the main advantages of chemical recycling? And we have seen 3 processes: one for polyester, one for viscose, for tensile fibers, and one for polyamide. Benefits, main advantages of this chemical recycling is there is, and let me be clear on this, there is less need for sorting. It doesn't say there is no need for sorting, there is less need for sorting of raw materials. The products can be reintroduced in the respective production cycle. So this makes sense, especially if you are producing your tensile fibers yourself, if you're producing your polyester fibers yourself, because then the dissolved fiber, the monomer, can be introduced into your actual production cycle, cutting out the need for an additional step. In any case, chemical recycling preserves more value than combustion because you maintain the actual chemical structure of the monomer. This is economically attractive. However, two preconditions. One is the scale of operations. This is nothing for small scale operations, and you should do it as a manufacturer of fibers who is running the actual process of the fiber production anyhow, or you should cooperate with one. But in this chemical recycling, we all see a lot of potential for the future. There are disadvantages, however. Investment cost tends to be high. We need some equipment, we need chemicals, we need to have closed cycles to contain the chemicals. An economy of scale. So in this kind of recycling, we are going for the bigger plants, minimum a few thousand tons of process waste per year. And we don't have all the options. If we look at if you remember the first slide showing us the multitude of available fibers, we have processes available just for a few polymers to do the recycling in a chemical way economically. Another approach, I would say, to chemical recycling is pyrolysis, where by heating the fibers, not by burning them, but by heating them, we sort of distill off monomers or oligomers and then process them further, ideally to a de novo polymerization. This is also interesting. There was a lot of research on this in the last years in Germany. Again, this is nothing for an individual garment company. This is economic only on the larger scale. Now, we touched sorting in a few slides. Principle of sorting today is to chop down the material. Here we have jeans in this image photo of Tomra. Tomra, you know, from the machines for reverse vending of bottles for deposit. They have also a strong division for sorting all sorts of materials. You chop down the materials, then you pass them on a conveyor below sensors, which are mostly near infrared sensors, and then the material passes are controlled by a computer, which receives the information about the individual chips and then shoots, so to speak, the particles into the corresponding container according to their color, or in our case, according to the infrared, near infrared spectrum he's collecting from the material. This works very nicely. This works very fast. Drawback, as you can imagine, is these machines do not come for free. So again, we are back with one of the major characteristics of all the processes I'm discussing today. There is economy of scale. This doesn't pay on the small scale. Sorting technologies are promising for recycling of production waste. It works. The purer, the less contamination by finishing additives, by dye stuff, the better. Again, like with most of the other technologies, we need to agglomerate companies. We need to work together. These technologies don't pay for the individual. So we need sort of a business model to combine manufacturing textile waste for processing. And for this, we need, of course, as we discussed earlier today, some regional proximity to minimize transport. Last sentence may be important if we think in these dimensions. In Europe, so far, most of these plants require public funding, require research grants, require some sort of support to make them interesting for the operators. Now, coming back to a current problem, the left table, the table on the left side of the slide, I would have showed you if we had had this presentation a year or 1.5 years ago, showing the relation of cost in euros per ton of the main materials, main plastics in this case, because for this we have the data, and for the corresponding recycled materials. And we would have seen that there was a nice margin, there was a nice economic motivation to use recycled materials, depending on the fraction, between 10 to maybe 30% was the benefit from using recycled plastics. Unfortunately, in the last 1.5 years, this situation have changed. This is another version of the chart I showed to you yesterday, this time by Bloomberg, one of the major consultants and traders, also in raw materials. And this shows that, unfortunately, at present, the price for virgin PET, this is now focusing on PET only, is cheaper than to use recycled material. The advances in technology, improvement in the recycling process, or reducing the cost of recycling process, could not keep pace with the changes in prices of virgin PET because of the distortions of the market starting already in 2019 because of reduced demand, or maybe not reduced demand, but more capacity to produce PET than there was actually needed. Barriers, limited purity of input fibers, we have discussed. Fiber length decreases, of course, with every turn of the recycling wheel. And cheap synthetic fibers have become important players in the field, which is a problem for recycling. I wouldn't say it's a barrier to recycling, but it's a challenge. Our last session now focuses on several topics which you have already touched in the last presentations of the group work. Let me explore a little bit more the elements of new materials, business models, and different aspects of cooperation. This is a roadmap which was designed by the consultancy McKinsey, which is not a small one, analyzing the fashion industry. It's actually quite recent. It was published this year. And I'm not going into all the details of this roadmap now, but it shows us the potential contributions of different technologies, different options to reducing climate aspects, starting from small things like using reused polyethylene for poly bags, to energy efficiency improvement, the use of repat and so on. And what I find interesting in this chart is that it shows the accumulated contribution to carbon dioxide savings, and it shows the financial aspects of the individual options. On the positive y-axis, we have measures which actually cost, which induce increased cost. And on the negative y-axis, we see savings. So basically all the measures in the left half of the chart actually are not only contributing to mitigation of climate change, but they are also economically interesting for companies. And there are a few ones, without going into all the details, a few ones which actually sound like a checklist for us to implement. Basically talking about materials. Somebody mentioned in the presentation cardboard poly bags. Increasing recycled content of these is not something to laugh at, but has a serious potential, of course now extrapolated globally, to help apparel and footwear companies to cut costs. Same like e-commerce, embarking further in e-commerce. We will discuss in a minute the aspects, because this is not simply or not only setting up a web shop. This includes much more in terms of digitization and data exchange and so on. With a focus here, reducing overproduction rate, because on the global scale, we see a huge amount of waste because of overproduction. Footwear, apparel, which cannot be sold because it's late in the market or in the wrong place of the market or not meeting the latest fashion and so on. And the global estimate is that 10 to 20% of garments and footwear are destroyed because they are overproduction. So one by one, we could discuss measures which partly apparently look common sense and simple, but do have a significant potential to improve the economic aspects of an enterprise as well as reducing carbon emissions. So just, it's not the time today to discuss all these aspects, but of course, all these slides are in the shared file folder, which Andre communicated earlier. And in the files, you will also find the links in the notes section, so that maybe if you have some time or so, you can go to the original charts and also have a look at the explanations, because this is a rich source of inspiration, and I'm sure one or the other idea can be implemented right away in the enterprises. This is basically a little bit different perspective, but discussing the same issues, what actually can be beneficial in terms of decarbonization and cost savings. And we have here of course, something that needs more explanation, but we will touch in a minute. Improving material mix, we have heard the vision of one single material for a sneaker, for example. I will show you a realization of this, still in the pilot phase, but it's being tested to improve packaging, Vitaly mentioned transport, retail has an aspect in these two circular business models and so on. So this is now one example I want to draw your attention to, because it might show a way. Can you imagine a sneaker, a running shoe actually, being used by athletes, not just hobby sports people, but real athletes, being produced from one material only, of course in different modifications and different forms, like foam of different hardness and fibers and so on, containing no glue, because all this is thermally bonded, no dyes. I mean, this is something we can discuss. This is more or less pure white. This is Futurecraft, which is a sneaker produced by Adidas. They produced some 20,000 pairs. They distributed it among assets for testing, and they recollected these shoes, and now they are evaluating this exercise, whether it's feasible to roll out this product on a broad scale. Because Adidas has announced that by 2025, which is 5 years from now, which is not too far away actually, they want to use 100% recycled materials. So fully complying with any potential legislation at that time, simply creating the basis for recycling, because this is one material only. So all the complications we have just discussed in the exercises would not apply, because separation of these is easy. And in this model, in this pilot model, no dyes, no glues, so no complications for recycling. Question is whether this is really the future, because along with this single material would come a new business model, which is being discussed, I think, internally at Adidas now, which, because to buy a sneaker, to use it, is the classical style of doing business. Now they are discussing how to implement other aspects, like how to return the shoe, how to melt it down, and how to use it again in production. And technically, things look good. Biggest problem is to organize this reverse logistic to collect the used running shoes. So this might be one direction for the future, that we rigorously reduce the number of different materials, but fully exploit the potential of a single material in all its modifications and different preparations and so on, to solve the problem of having to separate different materials during recycling. So could be one aspect of the future, TPU in different modifications. Another line of thought was also mentioned by Katharina, this compostable shoe. Allbirds is very close to this. It's not yet there, but it's very close to this. Look at the materials they are using for their sneakers. And the basic material for the uppers is merino wool, very nice, fine, breathable, and so on wool. Tencel, this fiber from Lansing we were discussing about earlier, as Adidas does TPU. Of course, cardboard for insole and so on. Let's see how this works over time. Interestingly, a very old finishing agent, castor oil, to waterproof the shoes. So no chemicals, no fluorine and so on, but castor oil, which actually is known to most of us in recent years only in arts. Sweet foam, which is foam produced from, basically produced from sugarcane, and recycled nylon, which is a little bit a disturbance in this menu of ingredients, in this menu of materials. So what the company has achieved is to reduce the carbon footprint of a pair of running shoes from 12 to 7 kilograms. And the goal, the final goal, a couple of years to come, is zero carbon emissions by using only bio materials which are fully recyclable. This is another line of thought. These running shoes are competitive. They are priced at 90 euros, which is pretty much average price for sneakers in Europe at present. And a good indicator that there is potential in the market to accept these shoes is that Amazon is selling almost identical copy at a reduced price at 35 euros. So they have taken the bait, they see potential, so they have a no-name product produced, which is in competition in the low price market, but following exactly these design rules which we are discussing. So probably we will see more of this in the near future. An interesting development from the sports market is a snowboard. Contains up to 30 different materials, from glass fiber, inlays, steel, edge, some rubber, and so on and so on. Recycling is almost impossible because you never can separate all these. Was conventional thinking until 3 years ago, until this company, Conora, came up with an epoxy glue which is reversible. If you cut the snowboard to pieces, of course, upon collection after use, you put it into a slightly acidic solution, basically with acetic acid, vinegar, and the epoxy dissolves, freeing all the individual parts so they can be recycled afterwards. So all the plastic, the thermoplastics, the fiber, and so on is free of glue because this is dissolved, the adhesive is dissolved, and all the materials can be introduced into recycling. There is a US-American company using this at the moment. And we have one big manufacturer of snowboards in Austria. They are experimenting with this product. Also, so probably in the very near future, also we will see this solution more, that we are using adhesives which we can revert, where we can stop the function of the adhesive when we do not need it anymore, and when it's a burden actually in recycling. Purton is actually the brand that is experimenting at the moment with a similar solution. Deep printing also has some potential, allowing to tailor to suit shoes, speeding up production, reducing the need for larger pre-series. New Balance is using this in some of their shoes, and the world record in marathon, faster than 2 hours, was done in Nike running shoes, where also the midsole part and some of the elements providing support for the foot are produced in 3D printing. So in combination with other materials, this 3D printing also opens possibilities for targeted production. And this comes again with aspects of digitalization. Here the point is, of course, to tailor to suit, to avoid overproduction of products which then by design or by size do not suit the market. And the point here, or the focus here, is really the integration of different solutions, of different software. If we read through this advertisement of Browseware, which actually started from digitizing human bodies to provide better measurements. They are now cooperating with Viso, which provides models for apparel, and they combine it with a fabric analyzer, which has all the properties and designs of fabrics, which is already combined with V-Stitcher, which provides you with support in layouting as a preparation for cutting and so on. So this digitalization on the long term will integrate, like in car making, fully digital twins of the designs we actually want to produce, from the measurements on the human body to the design, to the layout of cutting patterns, to production planning, and also, of course, providing the garments with a digital fingerprint, so that upon recycling we actually know very accurately we are talking about. Maybe also at some point the chemicals, the fibers we are talking about. So this is an aspect of, in Germany we say, industry 4.0. Actually it's full use of integration of software and using of a digital twin comprised of the data characterizing the garment, or probably the shoe also. And this offers, of course, then potentials also in better planning, avoiding overproduction, faster reactions to demand, and by this digital fingerprint as a basis for more targeted recycling. Recycling as of now can be represented by
Наразі переробка я ось тут на декількох наступних слайдах представлю кілька прикладів переробки. Здається, я вже говорив про це вчора. Nike зараз реалізує програму під назвою «Здай своє взуття». І в основному
with assets and because then they get bigger volumes, identical volumes back. They regrind shoes, and as we discussed yesterday, the main product then are running tracks, the surfacing of these tracks, for example, tennis courts, turf fields, gym floors, and so on. Carpet padding is also one product. So we can discuss whether at the moment this is actually recycling. It's more sort of downcycling, but still it's reusing these materials. Nike sees this as a playing field for experimenting for the future with more and more recycling. Now, in a nutshell, what conclusions can we extract from what we have discussed so far in this session? This is actually almost a quotation of Ivan's statement presenting the last exercise. Maybe to use one material on one product is a little bit too far in the future, but to reduce the number of components to the essential number is a good step. If we think about our wool shoe, to use components from natural renewable origin is a route. Biodegradable materials are a route. To use more and more recycled materials is one route. Definitely, the recommendation is to be careful in assessing the raw materials which we use so that there are no hazardous or restricted substances. This will be one strict rule for the future, because this would interfere heavily with any potential reuse recycling if we continue using materials like PVC. I mean, chromium is difficult to avoid in leathers, but ideally we should, in finishing shoes, fluorine-containing substances, we should try to avoid, because hydrofluoric acid is a nightmare when it comes to incineration, but also to recycling. Water-based adhesives, when we use glues, if possible, use less and less adhesives, and metallic pieces, as Katharina managed, are basically everywhere. They are interfering with recycling. They need to be removed. So where possible, we should come up with a plan to reduce the number or to avoid them completely. Now, starting this presentation, I started with this slide of McKinsey's roadmap for the fashion industry. This slide is taken from the same study, and what I would like to call your attention upon is draw as a major conclusion, which is pretty much summarizing what we are discussing they see these challenges from climate change to resource scarcity and so on as a chance for brands to take responsibility, okay, to take action, not to sit and wait, but to develop their response plans for the future, understand their own emissions, which is basically what we started with our waste maps yesterday, and collaborate with partners to decarbonize the value chain. And collaboration, we have already discussed a couple of times, becomes a key tool in working with the suppliers as well as with the clients or other key stakeholders. Few examples will follow in a minute. This example comes from an Italian manufacturer of walking boots, climbing shoes, La Sportiva. They're in southern Tyrol, in Alto Adige, where they have a cluster of such companies producing all sorts of sports shoes. And their problem, amongst others, is rubber. Because in all these hiking boots, you will have rubber in different modifications. And in the first place, you have rubber waste during production when cutting the pieces before vulcanizing them. But of course, also at the end of the life cycle, when you shredder these shoes, you end up with rubber. For them, as a company focusing on the core competence of making probably the world best hiking and climbing boots, to think of all the details of recycling rubber is a little bit far. Still, they want rubber to be recycled. This is why they cooperate with a dedicated company, which is located not far from them, who collects all these rubber waste. They do the pulverization, so they reduce the rubber to powder, and they also organize then that this rubber deriving from the technical waste, so from production waste, is reintegrated in the production of new rubber. So in order to follow this goal of recycling rubber, but not bearing the full burden of developing all the technology and having dedicated machinery and so on, they cooperate with a partner who does that for them and for other companies in the region. So this is, for me, also a road sign in which direction to think in the future. Xenoplast is an Austrian company. They are not involved in the footwear nor apparel sector, but they are involved in in materials for thermoforming parts for the car industry. And they have a very interesting business model because they supply the material, so the coil basically, to their clients. The clients make the parts by thermoforming, and part of the contract of Xenoplast with their clients is to take back the material and all which Xenoplast has supplied, and they take it back and they reintroduce it into their production. They try to keep this circle closed because they exactly know the material they are supplying to the client. And if they get it back in the pure form as a singular material, for them it replaces raw material in producing new coils. So this is really a form of symbiosis, which is good for the client, because basically there is no residual waste on their sites. And it's good for Xenoblast, because up to 20–25% of the material which they are producing actually is recycled from the clients. We could extend these models. This representation is taken from RECP, Waste Reduction Action Program of the UK government. And they use this systematic to represent the potential interesting business models, which range at the core of providing service systems. So this would mean this is like chemical leasing. You are not providing the product, you're not paid for the product you sell to the client, but for the function you perform. In chemical leasing, it's the cleaning or the lubrication. In textiles, the corresponding model would be you provide the service of protection, talking about protective work gear, or you provide the garments for hospital people, but you provide the function and you don't sell the garment anymore. Similar models are hiring, leasing, incentivized return. H&M does tests in some of their shops where you get a voucher for your next purchase if you return used clothing. So to make sure that the materials they know come back in a pure form and they can return it to their suppliers. This reuse is a big thing. I showed you these pictures of the vintage clothing stores which are mushrooming at present here in Austria, but as well in the rest of Europe. And to provide a long life, I will show you an example in a minute, what some companies are already doing and what governments are doing. You might remember one of my first slides yesterday showing how H&M is interpreting European legislation with the advice they are giving their potential clients in their advertisements regarding recycling and using clothing longer, actually. Just some examples what some companies are doing. Teso is an English company, at least they have subsidiaries in the UK. They offer a carpet take-back program because carpets usually are big volumes, a lot of material. They have a take-back program, which is basically more or less an informal, based on awareness. There are other companies who do not sell carpets, at least for commercial clients, but they rent them. You pay for the use of a carpet, and after a certain time, the company exchanges them for you and reprocesses the worn-out carpets. Patagonia, you probably all know as a leading provider of outdoor garment. And they, for the last 10 years, actually have offered that they repair their overcoats, jackets, and so on. In the US, especially in California, where all the hip people live or so, this is really working well. Duroflex is cleaning, repairing office chairs to avoid the textiles, the filling and so on, to be thrown away too many. Boot makers, repairing of shoes, it's become quite usual actually, where we have big quantities. In Austria, it's, for example, the army and the police who are using these services, that they get made available a certain volume of boots, and they can return boots to suppliers, also other suppliers from Altberg, and get them repaired and get them back. Taking you back to Austria, we have a very ceremonial event every year. Actually, next year it will be cancelled because of all this corona situation, where all society meets. It's about 5,000 people meeting in Vienna in a wonderful ballroom. And the dress code actually is full dress. So people will appear in these penguin suits. And of course, this is really expensive dressing. Average comes at 2,000 to 3,000, a full outfit comes at 2,000 to 3,000 euros. So most people don't buy this. Even the celebrities showing off there, paying the expensive tickets, do not buy their suits, but they rent them. And in Vienna, we have 10 or 12 of such rental services where you can rent your full dress for the evening and then you return it. So in some sectors, in some niches, the model of renting even clothing is very well established. Same in professional garments, like for hospitals. They don't buy them anymore, but they rent them. They return them, get them washed, get them replaced, and do not own the garments anymore. Now, RECP, this UK initiative, has analyzed these business models, and this is part of their results. In these tables, you see a financial appraisal of these new business models and an appraisal of their resource efficiency. Just to discuss this a little bit, there are several business models which at present in our environment do not work without subsidies. One of these examples would be, from a resource efficiency perspective, very advisable. These repair workshops is financially not viable simply because of the cost of labor. This is why we get public support for all these repair workshops, where you can get your clothing repaired, where you can get your electronics repaired. Other things, like I showed to you, I mean, the ecologic evaluation of the business model of renting these full suits doesn't look, full dresses doesn't look too good, but it definitely is a profitable business model. So people renting formal dresses for these receptions or for weddings or so, they make good business in renting the otherwise very expensive clothing. Interesting model is this buyback and resale, where some companies, some sport shoe manufacturers or walking boots, hiking boots manufacturers take back for some vouchers or a small compensation their products and sell them to second-hand markets like sports associations and so on. This is also a good business model. And the last one here, just to bring your attention, which is peer-to-peer exchange, which is like exchanging clothes in the family. This is not an economically viable option, of course, because there is no money involved in just exchanging materials. And the analysis found that from an ecological point of view, it's also not acceptable. This is linking to what Vitaly has said in the evaluation of the last exercise. There is simply too much transport involved. When people visit each other for trying on clothes, for exchanging on clothes and so on, there is too much transport involved, which is making this model ecologically not beneficial. But in a nutshell, all these models have potential. All these models, of course, have their own environment where they can be meaningful. And it's up to us to take these models as an inspiration and maybe can come up with an interesting new combination of materials, renting, taking back our garments or footwear to support a circular economy for the future. I promised you this example, long life of garments and so on. The UK government is issuing such leaflets, such brochures containing tips how to treat your garments, for example. And one of these tips, for example, is stain removal, because apparently it's not so commonplace anymore that people know how to remove a stain of red wine from a shirt or so. So the British government has produced a series of, all in all, I think 40 such tips, what to do, how to repair a sock, or how to fix a loose button and so on, so that people again start to care for their clothes, to have a longer lifetime, a longer useful life of their clothes. These are some recent examples in which direction maybe packaging goes, because this is, of course, the focus of much criticism with all these internet shopping and so on. Lots of waste packages and packaging materials are generated. Adidas for special sneakers has reduced packaging to the minimum, just piece of cardboard and a label. In some segments, this seems acceptable. Many people do not care for the box or leave the box in the shop, which is another approach. We have a regional brand for shoes here who asks you when you buy shoes, and if you decide to leave the box in the shop, they give it back to the factory and they reuse it. I mean, Vitaly's problem kicks in here. is it meaningful to allow for the logistics, for the transport? But this needs to be assessed on an individual basis. Puma is going another way. They actually design packaging for some specific sneakers for youth market in a way that the actual packaging is a shopping bag, which fits nicely now into the discussion of reducing the amount of poly bags which were distributed by shops, supermarkets, and so on for your grocery shopping. The idea is when you buy a pair of these sneakers, you get rid of the cardboard, but only the cardboard, and you keep reusing the actual bag as a shopping bag. Just one idea. Starting in selected shores take-back programs for their shoes, these and other sports equipment. This is what we are thinking of also. These donations were actually mentioned, that Adidas has a specific program where they, for example, collect from bigger clubs equipment and give it to clubs in need. It's a bit controversial, but at least they do it to test this market. And one thing, as we discussed, digitization, to see how far it can go. This Japanese brand actually provides with an app which collects the biometrics of your body, and you then send this data to the factory. They select among their sizes. They have about 1,000 sizes available, so that you get a perfectly fitting garment. And in case their sizes don't fit, they produce exactly what you need. The benefit for them at the moment is mainly to avoid returns and to learn more about their clients, to learn about, let's say, developments in body measures and so on, in population, to really know perfectly the demand side. Yeah, that was it basically from my side.